Assalamualaikum warahmatullahi wabarakatuh and Assalam sejahtera. My name is Muhammad Khamarana bin Muhammad Azam. My metric number is 231043534 and I'm from Program Material Engineering. So today I want to present about one of my assignment for subject Engineering Quality Control, and my title for this presentation is Quality Control Analysis Data. And for this assignment I got the data set number 002, and this data set consists of raw data for 3 machines that I will test later. And for the first machine, for the control chart, we got here that we need to use the pressure 200 kilopascal and the temperature 338 Kelvin. And for machine 1, we got that machine 1 process is out of control. This is because there's a one point that placed below the LCL, and for machine 1 the standard deviation are 1.497002 and the mean or center are 49.6353, and the LCL for the machine 1 is 45.1625 and the UCL are 54.14451. As for the machine 2, lower control limit and upper control limit can be read from the chart, which is 47.41107 for the LCL, and for the UCL is 55.16104. And as for the standard deviation and mean center are 512806, and for the mean and the standard deviation are 1.291663. And we can consider that this machine as in a control process because there is no number that violating any runs. Next, for the machine number 3, the lower control limit and the upper control limit can be read from the control chart, which is 45.88889 for the LCL, and the UCL are 50.67241. And as for the standard deviation 0.7972536, and the mean or center are 48.28065. And from this chart there is one number that violating runs, and we can conclude that machine 3 process is out of control. Next, we move for the process capability. The capability of meeting the length requirement for all 3 machines, and for the pressure 200 kilopascal and the temperature is 3.338 Kelvin. As for the machine 1, this is a chart for the machine 1, and we got from the chart that the CP machine 1 is equal to 1.11 and the CPK machine 1 1.04. And as for machine 1, the process is capable to meet the length requirement as the value of CPK is greater than 1. Okay, next we move for the process capability of machine 2, and this is the chart for the process capability of machine 2. And from the chart we can clearly see that the CP for machine 2 are 1.29 and the CPK for machine 2 are 0.958. And as for machine 2, we can conclude that the process is not capable to meet the length requirement as the value of CPK for machine 2 is less than 1. Lastly, the process capability analysis for machine 3, and this is the chart for the process capability analysis for machine 3, and we can clearly see that the CP for machine 3 is 2.09 and the CPK for machine 3 is 1.37. And as for machine 3, we can conclude that the process is capable to meet the length requirement as the value of CPK for machine 3 is greater than 1. Lastly, for the machine 1, the resistance for the pressure is 0.0000025, and which is less than 0.005. And in this factor, we can clearly say that P is not significant for machine 1. And then the resistance for the temperature 0.000025, which is also less than 0.005. And in this factor, T also not significant for machine 1. And lastly, the resistance for the pressure times temperature is 0.8358, which is greater than 0.005. And we can clearly say that P times T is significant for machine 1. Next, for the machine 2, the resistance for the pressure is also 0.0000025, which is clearly is less than 0.005. And we can conclude that P is not significant for machine 2. And the resistance for the temperature is also 0.000025, which is also clearly less than 0.005. And we can conclude that T also is not significant for machine 2. And lastly, for the resistance for the pressure times temperature is 0.8272, which is clearly greater than 0.005. And for this factor, we can clearly say that P times T is significant for machine 2. Lastly, for the machine 3, the resistance for the pressure is also 0.0000025, which is less than 0.05, and clearly is not significant for machine 3. And the resistance for the temperature is 0.0000025, which is also less than 0.005, and also clearly is not significant for machine 3. And lastly, the resistance for the pressure times temperature is 0.9225, which is clearly greater than 0.005. And in this factor, we can clearly say that P times T is significant for machine 3. Lastly, as for the conclusion, machine 3 is recommended as the best option. This is because machine 3 has the highest process capability, which is CP equal to 2.09 among the 3 machines, and the minimum capability index is frequently established at 1.33. The larger the CP, the better the quality. Besides, the CPK value for machine 3 also is 1.37, which is also the highest among the 3 machines. And the CPK that greater than 1.33 means that the process is better than the specification requires. Additionally, the machine 3 has the lowest standard deviation, which suggests more consistent and precise result compared to the other machine. And the resistance for the pressure is 0.00025, which is smaller than 0.005. In this factor, pressure is not significant for machine 1. I think that's all from me. Thank you.